Alright, I'm going to add one final modification to our project, which will make it not only visualize the motion after it was calculated, but we're going to make it visualize the motion itself like we had it in the beginning. And we're going to make it visualize the motion for each of these graphs. The way to do this is to simply use another nested loop and modify our plot function a bit. So how do we do this? We're going to first, let's remove this. First, we're going to say for j equals 1 to the positions of the point, like we had it in the beginning. So this loop will run for each point in each motion. And we have to think about our plot function now. When we are generating the plot, it looks good, so it goes like this. It goes like this. But it's actually not one giant parabola. It's not very it's discrete. So what we actually have here is tiny little lines that make up this plot. We have tiny little lines between each of the points that are generated. We have to plot each line one at a time. Let's first use markers. So we're going to use x of I and j and y of I and j. So here we're generating matrices for the x values and for the y values. So by using two nested loops, we're going to walk through each of the elements in these matrices. So x of I and j, y of I and j, and let's create markers on all of these locations. Let's run it. We need to move our pause function inside this loop like this. So there we have it. Now it's too slow because our pause function is slow, so let's do it. There we have it. Now you can see each of the motion is being visualized, the motion itself, it moves on to the next motions. So how do we make it in a line? I don't really like the markers when it just gets too crowded. The way to use the lines is to give it vectors every time of 2 points. Two connected points. So we're going to give it the first point, which is x of I and j. The second point will be x of I and j plus 1. So what exactly is that? Here we have our x matrix of values. We have rows, we have columns. Our outer loop is working on the rows, so our outer loop says, alright, you're now working on the first row of that matrix. Inner loop is going through each of the cells in that matrix. So it's taking the first value first, then the second value, the third value, fourth, and so on until the end of that row. And then the outer loop will move on to the next row. What we are doing here, when we say x of I and j, when I and j are 1, we're taking the first value. When we say I and j plus 1, we're taking the second value. So we're creating a mini vector of these two values. On the second iteration, the I is still 1, but the j will be 2. So now we will have j2, which is the second element, and then we have j plus 1, which is the third element. So we will create another mini vector here. And we are plotting mini lines to form our final line. So let's do the same thing for the y of I and j plus 1. And we must remove the markers here. Let's try. You can see that now it's working, but we get an error. We get an error saying that we exceeded the matrix dimensions. Why is that? This is happening because positions of the point is 50. We have 50 positions of the point. The final element in each row is at index 50. But here we're saying 50 plus 1. So here we're trying to access the 51st element, which is not available. It's non-existent. The way to fix this is to simply subtract 1 from our iterations. So this becomes 1 to 49. In its final iteration, j will be equal to 49. So it will take the 49th element, and then we'll take the 49th element plus 1, or the final 15th element. If we run it again, we should not get an error now. There we have it. It's now working, and we get each of the motions visualized. Now, To make it smoother, to make the motion smoother, you can increase the positions, you can increase the points. If we use, let's say, 300 points, and we run it again, you can see that now the motion is a bit more smoother, it's a bit more gentle if you want. It's also going slower simply because we have a lot more points that we need to recalculate and visualize. Finally, what I want to do here, let's move it back to 50 points. Finally, what I want to do here is still add our colorful lines. Now, keep in mind that if you don't use the color here, let me show you. If you don't use a color here, you can see each of these mini lines. Each of these mini lines is in different color. And this is not very pretty, it doesn't show everything. So what I want to do is this. I'm going to keep the red color here. So while it's being plotted, it's going to be in red color. Once it finishes the motion of a given plot, it's going to give it another color from here. So it's going to plot the full plot on top of the red plot. There we have it. They are much better. And this is it. This was pretty exhausting project. I hope that it wasn't too complex, but now everything you need to do in order to generate a graph that will show you the motion of a point is you have all of your conditions in place, you have all of your equations in place. Everything you need to do is simply change the initial conditions. If you change even a single initial condition, everything below it will be reflected. So here, if I change the angle, if I make it p divided by 8, we should get more different results. They actually may look the same, but if you look a bit closer at our limits, the limits changed. We have different x and y limits, and we are probably not going to go as high. Even if we go as high, visually, the limits are different. The limits are reflecting these changes. So, this simply proves that the motion that is controlled by the gravity of Earth is not dependent on the velocity, it's always going to be a parabola. So, if we change this back to p divided by 4, you can see that now we get different limits. We had from 0 to 4 point something, now we have from 0 to 16, and on the x-axis we have up to 20, what is it, 27, I guess. There it is. In the final project, in the functions section, we are going to refactor this code because it's a lot of code, it's easy to get lost in this code, and we're going to spread it across several files.